Hi, this is Maggie. In this video we're going to talk about programming motion within a background that is larger than the screen, requiring the background to scroll. I'll illustrate what this motion might look like by running listing 9.8. When the program opens, we see a background that I call an ice castle with a penguin on the left side of the screen near the bottom. The user can move the character using the right and left arrows. So if I use the right arrow, the penguin moves right, and if I use the left arrow, the penguin moves left. If I get close to the right side of the screen, the background starts to scroll. I know it looks silly when the penguin moves over the pool with fish. I put that in there to illustrate that the background is a large image with some variation. Now, once the background scrolls so that the right side of the background image aligns with the right side of the screen, the penguin starts moving again, and he can move to the very edge of the screen. The program has the same behavior when the penguin moves left. He moves away from the edge of the screen and toward the other side until he comes within a set distance of the edge, and then the background scrolls until the left side of the screen aligns with the left side of the background, and then the penguin moves again. Here in an image editor is the icecastle.jpg image, and I've superimposed the penguin image over it. You can see how long the background image is. In the program, we see only 480 pixels of the width at any time. So how is this done? Well, we have a background image, and we have our screen, which is smaller than our background image. At the end of our game loop, we assemble the image that we're going to show the user like a single frame of a movie. We will want to assemble a frame that includes some part of this background and our penguin based on what we last showed and whether the user is clicking an arrow key to move the penguin. When we blit the top left coordinate of the image being blitted within the screen or other surface that we're blitting to. That coordinate can be outside of the screen's visible area. So I can blit the background to 0, 0, like I usually do, and the top left corner of the background will line up with the top left corner of the screen. If I blit to a negative x coordinate, though, then it is as if the screen has moved to the right over the background. This is figure 917 of your text. In this figure, you can see that the background x coordinate is far to the left of 0. That is a negative x coordinate. This darker blue box represents the screen. When the program begins, the background is blitted to 0, 0. And the penguin, represented by this white box, is near the bottom left of the screen. The penguin can move right until it comes close to the edge of the screen, to a coordinate I'm referring to as the scroll threshold. And then if the user continues to move the penguin right, the background moves left. This gives the scrolling effect. Once the background has moved so far left that the right edge of the background is the right edge of the screen, the penguin can finish the journey until it reaches the edge of the screen. Let's write a program that allows us to scroll a background, and then we'll add a character to the program. I'll work from our template, which I've renamed to scroller.py. The background is going to be blitted to locations other than 0, 0 in this program, so I'm going to annotate some variables for the background. bkgdx bkgdy, which I'll initialize to 0. I'll also give the background a speed, which I'll call bkgd dx, and I'll initialize that to 5. Now, I don't want to keep poking the arrow keys. I want to be able to hold the arrow keys down. We can set something called repeat in Pygame, which will replace the key down event in the event queue for as long as we're holding a key down. But I think a better way is to keep track of that ourselves. So I'm going to annotate an integer variable called moving, and I'm going to set some constants: left, right, and not moving. And I'll initialize moving to not moving. And then I need to load in the background image. And once again, I found an image on public domain vectors that I like. This cityscape. It's fun to work with somebody's good art as opposed to my terrible amateur art. But remember that you should know the origin of any work you use, and you should obtain permission, if necessary, before using the work in any public way, even if you're not making money. Down in the event loop, we're going to respond to a key down event by checking if we have a left or right arrow and setting the moving variable to the appropriate constant accordingly. And we'll process a key up event by setting the moving variable to not moving. Okay, and then what is left is writing the moving code. So I can write a conditional statement, if moving equals right, and I'll move the screen to the right over the background, which means I'll move the background to the left, since that is what's actually moving. And then elif moving equals left, where I'll move the screen to the left, meaning in reality I'm moving the background to the right. And this code is going to be written the same as when we move a character. For moving right, I'll subtract background dx, or the background speed, from the background's x location. And for moving left, I'll add background dx to the background's x location. And then in each case, I'll have to do some boundary checking so that I stop when the edge of the background reaches the edge of the screen. For moving right, in which the background is moving left, if we go back to our figure 917, I have to check that the right side of the background is less than the right side of the screen. The right side of the background is, just as with any moving object, its x location plus its width. So that code looks like if background x plus background.getWidth is less than screen.getWidth. And if it is, then I just want to set it back to exactly the width of the screen. But because background x is the left coordinate, I'll set it to screen.getWidth minus background.getWidth. And if it's moving right, then it's easier because I'm dealing with a left screen coordinate of 0 and the x coordinate to which I'm blitting the background. If that's moved beyond 0, then I set it back to 0. I want to make sure that I'm not blitting to 0, 0, but that I'm blitting to background x, background y. Let's run that and see how it works. When the program opens, I see the left side of the background image. Pressing right and left arrow keys scrolls the background. And if I hold the right arrow key, it stops when the right edge of the image reaches the right edge of the window. Now let's add a character to the program. I'll annotate and initialize a robot x variable to 0, and I'll annotate a robot y variable and a robot surface, and I'll load the surface and set the robot y location to the height of the screen minus the height of the robot, so the robot begins in the bottom left corner of the screen. I'm going to change the variable background dx to simply dx because we might move either the robot or the background, but the speed should be the same. We'll need one more variable, which is the scroll threshold. If the robot is within scroll threshold pixels of the edge of the screen, we'll move the background instead of the robot. I'll set that to 100. At the bottom, I'll blit the robot. And change the background dx references to dx. When we run the program, it runs as before, but with the robot in the bottom left of the screen. What we want is for the robot to move until it gets close to the edge. And then if the background can move, the background will move. And if the background can't move, then the robot will move to the edge. And we need to make that check for both edges, depending on which direction the robot is moving. Let's start with moving right. And I think I'll annotate some variables down here to make these calculations easier to read. I'm going to create a variable called robot right, which is the robot's x coordinate plus its width. And I'm going to make a similar variable called background right. So if we are moving right, then we want to check if we're moving the robot or the background. We're moving the background if the robot is within the scroll threshold on the right side and there is background still to the right of the screen that we can move. So I'll write that check as if robot right is greater than screen.getWidth minus scroll threshold, which is the part that checks that the robot is within the scroll threshold of the right side of the screen, and then and background right is greater than screen.getWidth, which is the part that checks that there's still background over to the right that we can scroll. And if all that is true, then I can scroll the background as before. And if not, I'll move the robot by adding dx to the robot's x location, and then checking that it hasn't gone beyond the right side of the screen, and setting its right side to the right side of the screen if so. Let's run it and see how we did with that before we write the code to move left. Okay, I press the right arrow key and the robot moves. And I wrote out the full word, background right, instead of BKGD. Let's try again. Okay, once it's within threshold distance of the right edge of the screen, the background moves. Once the right edge of the background has reached the right edge of the screen, the robot moves again. And this is also an interesting error that you might make accidentally. I forgot parentheses on a method call. Let's fix it and run it one more time. Okay, now we can implement moving left, hopefully without errors, which is a little simpler. I'm moving the background if the robot's left edge is within the scroll threshold of the left side, and if there's background to the left of the screen that can be moved. So I'll write that test as if robot X is less than scroll threshold and background X is less than 0. It's simpler because we blit to the X coordinate and the left edge is 0. And if that's all true, then we'll move the background. And if not, we'll move the robot and check its boundary if it's moved beyond the left side of the screen. If robot X is less than 0, robot X equals 0. This is the easy side. Let's run that and see how we did. Okay, so I'll venture out enough to get the background to start scrolling, and then I'll move back. So it's working correctly in both directions. That's a way to create a side-scrolling game, but you can also use this motion in all directions. It's important that you understand how to calculate your boundaries and how to write the tests, which comes with understanding the mechanics of this motion and the quantities involved. I'd say to study figure 917 and then rewrite the scrolling code until you can do it without looking at this code or the book's code for a reference, and then adapt it to scrolling top and bottom rather than side to side. Once you can do that, you're ready to move on.